Okay, good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon to try and figure out the future of smart buildings and all of the technology related thereto. In case you're wondering who we are, profiles are listed on mondaylive.org. Also, a point to note, to remember is that views expressed here are personal, so none of us are representing any company or organization. And let's make this as interactive as possible and put comments and questions on chat. And this deck is available on mondaylive.org in case you want any of the links. So this is the third week in November where we have been talking about system of systems. We talked about the basics of what system is all about in the first week. And then last week, we were talking about how ontologies and system of systems relate to each other. And this week, after normal sort of news and trends chit chat, we're going to take the grid and specifically how grids and buildings can or should work in the context of system of systems. How does system of systems help that kind of thinking with making that a reality? Because it's becoming more important as we start to electrify more and more of the systems in building. So that's the plan for today. But before that, hand it over to Ken to give us an update on what's going on.
Thanks, Anto. A lot's going on. We're hard at getting our program together for AHR Chicago. And of course, it's our 25th year history or anniversary, and we've been assembling our history. And even I'm surprised at the amount of stuff we've collected. One of the jabs when I was trying to figure out what to do with automated buildings is they told me to gather together my people and turn it over to them. And what I determined is my people is the industry at large. And when we see how much you all have been involved in automated buildings over the last 25 years, it's quite a tribute. Anyway, we're trying to figure out how best to depict that. We have our agenda online, which is moving along, and you got to keep looking at it because it's dynamic and there's people popping up every day that are committing to speak, and programs are evolving, and there's some minor changes to the sessions. So we're pleased with that. We're putting a lot of emphasis on having our moderators and hosts have their input for their sessions. We're starting to do some flyouts, and we're starting to share information beyond the speakers and give you links to their sites and to some of their works to try and do that. One thing I found out that was interesting this just in the last few days is our local telco company, it's called TELUS, has been working with Code Labs, and I hadn't quite seen that one coming, that all this work we're doing on the IBB and people who are working in that cloud native space, they're actually building bridges that will allow the telco companies. And what seems to be evolving is that the telco companies will be offering a service basically to link to automation systems, and for the probably the middleware buildings. I mean, we all kind of work with the 50,000 square foot buildings up, and there's all of those 10,000, 15,000 buildings with smart stats in them, and that whole thing needs to be serviced. So it's an interesting play that I hadn't seen, that we were working on that as we started to develop some of these concepts and ideas, that that was a good latch with the telcos. So anyway, that's just by the by, that an observation I made. In addition to that, I did an interview with Eric, and as it turns out, it was the last interview with Eric, because Eric is riding off into the sunset, and it's been a long relationship with Control Trends. We always used to joke that I did the words and he did the videos, and I think words and videos have kind of gotten mushed together in the new presentations. Actually, the interview does I ramble on, but I mostly talk about how we came to to the new automated buildings, the reinvention and where we're going and why you might want to come to Chicago to see what our plans for the future are. In addition to that, we're starting to pull our history together, as I mentioned, and one of the things we've done is over the last 7 years, we used Pinterest as our menu system. And so we actually automatically have all of the last 7 years in a video blur of drawings or Pinterest pins, I guess they're called. And you can actually click on that and you can just scroll through the last 7 years. And it's kind of interesting. It's a quick way to just take a look at the depth and the width of automated buildings. I think that's the bulk of what I have to report. Back to you, Anto.
Thank you. What you mentioned about telcos is interesting. One of the feedback that we got when we went to Realcomm in Vegas last June, or whatever it was, Jim and I actually presented about cloud native and the IBB at Realcomm. Mm-hmm. And one of the groups of people that got really excited were managed service providers. And the reason is that the managed service providers, one of the main roles that they play is that they manage the intersection between where the telcos come in and the building systems, right? There's always an entry point, usually some kind of fiber, obviously big internet kind of connectivity for voice and everything else, but that's managed by MSPs. And so Jim and I got a whole bunch of MSPs that's what they do. And they got excited about IBB because they saw immediately that that's a box that goes there. In other words, it goes into their domain. So they got really excited. Right, Jim? So that's interesting that you're sort of bringing up another data point of that.
Yeah, they've got a project that they're actually working with VHA, which is Vancouver Island Hospital. Right. So interesting. I hadn't seen it, but it actually makes sense when I think of it. And they're getting into home security and home health. So why isn't building automation just another app you can download? So I think it sends a clear message that we're truly coming out of the closet as an industry. We've always been pretty closed, but we're starting to expose ourselves, and we're in for radical change for sure.
Cool. All right, so moving on, I actually in sharing this article that I'm actually going to talk about a little bit later. It's an article that actually explains what's going on in the grid space in terms of the architecture of the grid, and there's a lot of conversations, obviously, in the grid, in all of the national labs and the utilities and a whole bunch of other things. I see Ron Bernstein is on the call. He's involved with Gridwise Architecture Council, so he knows about all of this. And this is an interesting article published in Vox recently that I got. So that's why I brought it up here, and I'm actually going to go show this article and use it to explain what's going on. So that's kind of an interest. That's the reason I put it there. Beyond that, Rick, that's not next week, it's the week after, right?
The week after, right, December 7th, we'll be doing the monthly office hours. And again, this is an opportunity for anybody and everybody to just call in and get a chance to learn more about what the coalition is working on, specifically with 2525, Division 2525, and the IBB, and our endorsement of Cloud Native Computing Foundation practices, Kubernetes for buildings. And anybody who's got questions about what the coalition is working on, just sign up for that office hours, and we'll answer all your questions and discuss maybe how you can even be more involved with what we're planning for AHR. I think the AHR is the next slide.
Yep, it is Smarter Summit.
Yeah, go ahead.
Yeah, so this is starting to come together. We're actually working on the agenda, so probably next week or the week after at the latest, we'll have a website up. But it is on the agenda of HR itself. If you go to HR and look at all their free sessions, you see Smarter Summit right there. So just to remind everybody that it's there, and it's happening on the Sunday prior to the opening of AHR. So make plans accordingly. And our normal links, and just pause here for any other thoughts anyone want to bring up. None being heard, we shall move on. So System of Systems, talking about the grid. So let me go through this article that I linked in my slide. So what this is trying to do is sort of explain how the grid works, and especially from a perspective of DER, distributed energy resources, solar panels and stuff. Right. So this is an article trying to figure out what's going on here. And I'm just going to hit the graphics. So this is how the grid system works. There are power plants, and there are some transmission that happens at that sort of power plant level. You see these when you're driving across country, and then that gets into local distribution, which get obviously smaller and smaller wires until we get to our homes, which is the smallest sort of consumer in the whole system. So this is how generally everything works. But the way it's organized is actually more like this, because the operators, the companies that operate the generation and the transmission is its own thing. So those are kind of companies that do nothing but that, and quite often they just do either transmission or generation, so split even further. And that is typically different from how the distribution of the electricity is managed. That's done by different people. Again, some cases it's the same people, but in a lot of cases it's different. And this is kind of how the distribution, how electricity gets distributed to all of us. And so with distributed energy resources, with DER, you basically have DER drawn here at the bottom, the sort of feeding power, not from the transmission side of the, not from the generation, but obviously from solar and wind and generation, right? So the code goes into the consumers, as it were, from underneath. Right? So the question is how it does that. And I'm paraphrasing and sort of jumping around the explanation. So that all works. So I'm jumping around here. So this works actually quite well, but as you see there, you know, a particular DER resource is only going to be feeding one consumer, right? So this doesn't work at scale. It works to some limited level. So people then start asking how do you get the DER into the transmission layer? And you kind of start to draw pictures like this to say you can actually channel the energy all the way up to the transmission layer, right? But how does that get managed? That becomes the problem, because the answer to that then becomes the TSOs, the operators that work at this level, would be the entity that manages it. So that's typically utilities, right? So they are sort of the central sort of piece. Right, so this architecture is ends up looking like this, because you really can't manage such a big set of distributed energy resources from a central core. You just can't. It's just too difficult. And the architecture of the whole thing was not designed for this. So you get a spaghetti mess, right? And this is, from a systems perspective, this is not scalable. This really doesn't work, right? So really this article goes into a lot of details of sort of a bottom-up architecture that in this article they're talking about the layered something or other, layered decentralized optimization, where you have the systems, the lows at the bottom that can actually communicate not just with one layer, but multiple layers as and when they need to, right? So how do you organize that? So you organize that using a sort of a tiered structure like this. So you have the TSOs, you have the distribution, and then you have the DER, and you may actually have multiple layers of DER carrying on forever. Well, maybe not forever, but for a number of different layers. So that then gets into what a lot of people are calling microgrids, right? So you think about each collection of consumers as being in a microgrid that connects to each other. And here we're starting to see system of systems, right? Because you can start just to think of microgrids, each of the microgrids as being a system of systems. And it goes into a specific example of a hospital having battery resources and generation and other sort of things. And this is not talking about DR specifically, but it's actually the same kind of similar mechanisms it's using for DR. So this then becomes a system of systems that's actually very similar to when we start talking about IBB and what happens inside a building. It's actually not much different to this. And you can even go, and this goes into one level further to say that you can actually have a separate part of that hospital in this particular example that is its own system of systems, right? So I just kind of want to bring this up briefly because the grid is inherently complicated, and really what's happening in the grid space, and I'll let others sort of chime into this, is trying to make it more nimble and make it more suitable for the sort of distributed generation and the distributed demand response type applications that we're seeing. So with that, I'm going to stop my share and then, because essentially what we want to get to is this. This is a slide from last week. It's not exactly appropriate for this week. What we want is kind of a system of systems approach, so we can think of the building as a system of systems and then think of each of the systems inside that building as a system that can also participate in this sort of fractal sort of mechanism. So the point here is that a central entity is very difficult for a central entity to manage thousands or millions of nodes of endpoints. Right, so that this work is all trying to figure out how to architect the something as complex as the grid. So I'm sure others have views. So I'm going to stop my share here because I think I'm running out of my grid expertise. Who wants to chime in to?
I'll chime in for a minute. I think that we've been looking at demand response and grid interactivity, over a 30-year period, and one might ask the question, why hasn't it been mature, or why hasn't it happened thoroughly so far? And the main reason is the regulatory regime in the United States is state by state, and each state has come up with its own rules. And if you're a manufacturer of equipment, it's hard to have 50 variants of the product to sell in each individual market. Now, some of those have been regionalized to independent system operators in terms of those rules. But what Systems of Systems does for us by decentralizing that architecture is it decomposes us into a structure that can actually work in those 50 markets, because the concepts are largely the same. And by having System of Systems, it allows us to have independent systems that can tailor. It's the flexibility or the ability to localize that in each particular state or market, which is going to help this really move somewhere this time.
Yeah, I think you said, I think last time on one of our other calls, you talked about the concept of loosely coupled systems of systems. And that's what has not, in my mind, that's what has not really existed, is the technology to allow for loosely coupled layers of systems. And engineered systems, as Anto had on a slide last week, everything was an engineered system from top to bottom, as opposed to thought about as a loosely coupled, shallow integration system that by definition is going to work with other systems. And that was that's different. So over the last 30 years, there's been there's been a technology deficiency, not just a complicated regulatory environment, but also a little bit of a technology deficiency.
So Anto, just a question for you on the article itself, which I have not read. I'm curious in two fronts. One, the grid, as I understand it, if we were to have a very significant shift from gas powered to electric vehicles, there isn't enough capacity or you can't distribute that much electricity over the current grid. Does the article discuss that particular problem? Because as I understand it, that's going to be one of the big constraints if we're to realize this electric vehicle future.
I think the issue is that it's the time issue, right? Because what you can't do is you can't have all of the electric vehicles plugged in at once.
Right.
Right. Either in a state or even in a neighborhood. That's if you combine all of the charging required for all of the cars, if everybody's charging at once, it will blow up the transformers over and over again. Right. So it's always a time issue. And so a lot of grid technology is about shifting loads, moving loads, so that if you actually move loads, so that if you have 10 cars that needs to be charged in the neighborhood, as long as you do it 2 hours at a time, one after the other, you actually have plenty of energy. It's just you can't do it all at once. It's what happens across the wire.
Yeah, just from a practical standpoint, that's not going to go over very well with the consumer. But putting that aside,
if it's automated, do you use your car between when you get home from work to when you need it in the morning? No. When does it get charged over that period of time? Do you care? Probably not.
Yeah, probably not. Okay. Well,
and you use economics, Steve. You have different prices. If you urgently need to charge your car, you put in a higher priority and you pay a little more, and the guy that wants to save charges his later. Let Adam Smith's invisible hand fix it for you.
That's true.
It's interesting that in comparison, when you look at the internet, when you're as it's combined together, you have no idea where your information
The article is channeling. How is that being
Steve, your audio is breaking up.
Utilities and the government entities. Yeah.
So
was there anything mentioned in the article about the government utilities working together?
I think it's interesting that when you look at the internet, you could be tied in through Sydney or Munich or whatever. It's shifted around the world where the loads can be balanced, because some of the centers are actually not being used, and so they actually do shift that around. I guess it's something, particularly in the US there, where you do have all these different companies, that maybe at some stage there's going to have to be some legislation that pulls them together if there's that sort of challenge for the grid. In the UK, we're kind of lucky. We're one small island where it's kind of connected, but there's still something like 3,000 or 4,000 microgrids out there and even more being pulled together at any one time. But all the wherever there is wind or there's panels, they are being connected directly to the grid mostly.
And I think if you look at some of these barriers, as I see it, is I look at it from kind of 4 different perspectives, or 4 general barriers or walls that we still have a long way to go as far as an industry. So one is the continued lack of standardization and interoperability. Obviously, System of Systems is helping, adoption of that will help that type of thing. Number 2 is look at the aggregators, the installers, the ESCOs, the utilities, that it was already said about the different markets and the restrictions, the restrictive wholesale, everything that has already been said. 3, where I think is a big one here, is that there hasn't been a very good value proposition communications done to the building owner and operator. I think there's still a big lack of awareness, a lack of understanding. They look at it as the technology to do this. And Rick, you mentioned the technology, too complex, too expensive. And then, from the utilities perspective and talking to some utilities is ultimately they don't trust. They're having a trust issue. So I think, we still have many barriers that I think need to be addressed. And my question then is this: who addresses those? And is it the manufacturers, like the technology manufacturers? Is it the utilities? Is it consultants? Who takes on that ownership?
Well, if you ask, I spent 7 years in the smart grid space, right? So I got to a lot of these kinds of questions. If you ask it in the utility sort of industry, or the power industry, they call themselves, a lot of the thinking, certainly back then, this is about 10, 15 years ago, was that the way this should all be done from a utility is that sort of the top-down approach that I was showing from the article, that the utility controls everything, right? It gets to the point where the utility would say, we should be controlling your appliances in your home, right? That was kind of part of some of the statements that I heard. And that, just from a system perspective, that will just not work. You can't go all the way. You can't have an architecture that controls to that level of detail, that level of granularity from a central point. That just doesn't work, right?
I think there was another thing that didn't work, which is the utilities didn't want to share any of the rewards, right? So a lot of value accrued to the utilities at that time and very little accrued to the owners. The other regulatory problem you had is that whenever demand resource was limited, they would introduce demand programs. And whenever there was plenty of power, they would withdraw those programs, destroying all the businesses that had been set up to do DR. So, if I chart over a 30-year period of my career, the number of times there were at least 3 cycles where big programs were launched and companies were launched. And when the demand went down, the programs collapsed and the companies collapsed with them. So I think that there's a better view from a regulatory standpoint now that people understand that if you want to have these resources, you need to make sure that those rewards are shared equitably, not just as profit centers for the utility.
There's another difference on the demand side, because you can think of in residential situations, right? You can sort of imagine, in California, you get sort of a text or something that says power is expensive now, so curtail your load. As a consumer, I can do something about that, right? I can not do my washing or something like that. But if a commercial building, a large 1 million square foot commercial building, gets that signal to say, we need 5 megawatts in 2 hours, something like that, then the question is, how does that get executed in that building, right? Because you can't just turn everything off, right? You got to orchestrate things. You can't just turn off that particular air handling unit because it affects a whole bunch of people, and there's a lot of orchestration that needs to happen, and the utilities could never do that. Could never
That's
reach
correct.
into the building.
But 15 years ago, Anto, all of the large customers, the pharma companies, the universities, the hospitals that are of that scale, they just said no, because the financial juice wasn't worth the squeeze. And that's not the case now. We see people actually, doing programming schemes throughout their building automation systems, where the energy management and facilities people at those facilities are making decisions, and the building automation systems are receiving signals like OpenADR or others, and responding to them. And I didn't think it would necessarily ever happen, and it is not happening on any mission critical. They're not doing it on operating rooms, and they're not doing it on regulated pharma facilities, but they are doing it to labs and offices that are adjunct to these things.
And as we get more and more capabilities on the edge, things like IBB and stuff we were talking about, then it becomes much more feasible for that entity. And we're actually doing this as part of the demo for AHR and IBB. You can actually have an application running in the IBB doing that orchestration, right? Understanding that, no, you can't just switch off a boiler and just turn the power off to it or something. You need to do a whole bunch of other things that the BAS system would totally understand. So you have this sort of impedance matching what needs to happen in the building to the sort of the big power switches that comes from the utility.
I think a big part of this are points of decoupling, right, in this whole thing. So we're working with a number of entities to add our platform as an aggregated load to a demand response program, right? So in our case, you've got lots of little buildings that on their own aren't interesting to a utility at all. But if you put 20 or 30 or 40 of them together, all of a sudden that's an interesting load, right? The challenge, of course, it's when you've got a portfolio of these little locations, depending on where they are and what kind of business they are and what time of day it is. I realize that low demand peaks occur typically late afternoon, early evening, depending on where you are, but not all of them may be able to participate all of the time. So you have this series of decisions that are made going up of which systems to add, one from each of these locations, which locations, and then our load goes into a bigger load by yet another layer in there in the demand response platform that is connected to utility platforms, right? So that is probably the one of the best examples of a loosely coupled system or system of systems pulled together in a way that it now makes sense to tie that to the grid and have that as part of what's going on, right? So it is happening out there. To Jim's point, it's interesting again. And now Ron Bernstein made a comment in the chat that it's really not so much a technical issue. It's other problems, and that you kind of opened with that too, Anto. Mm-hmm. So I truly believe that's the case in our situation here. So
one example of this is actually Nest. I know that quite a few people on this call typically would have a Nest thermostat, but a significant part of their business model is actually to do DR, even though you don't know it, even if you have a Nest, right? Because they can aggregate all of your homes. And I've just looked it up online I asked Bart how much revenue Nest gets from DR. Anybody want to guess what Bart thinks? Somewhere between 3 and 12 billion up in 2025.
Good.
So that is a sort of an example of a system of systems that's sort of basically doing aggregating and doing that sort of bottom-up management that we were talking about.
Okay, I wanted to bring up another opportunity, I think, that falls into us to add even more systems of systems as we're moving up in the Pacific Northwest here more to electrification, and we're actually demanding that. We're actually finding that the solution to a lot of electrification things is what we call hybrid mode, where we actually leave the carbon producers in the building, and then we orchestrate them based on the requirements of the utility company. So we're starting to see an interaction there. And then the other exciting piece to me is some of these in-building storage devices. As long as Jim always points out, as long as utilities is willing to share their problem with us, whether it be transmission or whether it be generation, we can be very flexible with our systems of systems, and we're starting to see new new technologies. One of the new technologies I've seen and is MZinc, where they store the electrolyte that is used in the battery. And so rather than having a battery of monster size, you just store the electrolyte and then feed it back through. So we're starting to see new technologies. All of these become, in fact, systems of systems, but it allows us to keep it closer to our chest, our cards. And I think that is, as a building industry, I think those kinds of systems are more attractive to us as long as the utility gives us the financial freedom to do that.
I just put a link in the chat of a company that happens to be one of our customers who's actually doing it. And they actually quote systems of systems on their homepage. And it's all about the grid and distributed energy. So we don't have to cover the specifics, but, and they've made some really good traction in US government, military, and 3 large commercial property owners, 1 in Canada and 2 in the US. So generally what we're talking about, it's being done, but not to, a point where it's happening every day. Let's put it that way, I think.
Yeah, one of the learnings from the IBM paper of 2010 that we were talking about last week is that you can actually have industries behaving as system of systems, although it's not being managed as system of systems, and you actually lose a lot of efficiency because of that. And that's kind of, I know it's a little subtle and a little bit sort of difficult to think about what that means, but the system of systems really talking about the information flow, right, and the organization of the different systems that should, that need to share information with each other, right? And quite often when we're talking about systems, and as we have been here, we're not really talking about the information system. We're talking about the structure, like transmission, utilities, and consumers, right? So you can actually create a structure that is a system of systems, but you're not using system of systems kind of thinking to make it work that way. And because of that, you lose a lot of efficiency, and that's a sort of a technical, at a technical level. And the other point that Ron's just brought up, a great point, is that the grid was not designed for a two-way flow of energy, right? And it really also, trying to read the rest. Yeah, I would also add that it wasn't really designed for real-time energy, real-time control two ways as well, right? Because the grid was always designed as being a one-way, here's energy, and I'm just going to assume that you're going to want that light bulb on all the time. I don't even know when you switch it off. I just know that you need less energy. So,
Anto, how's my voice now?
Good.
Okay. Yeah, Ron's point in the chat and what you just brought up is where I was trying to go with my second question, which is, does the article talk about not just the two-way flow, but really the players involved? Do they recognize the challenges, and is there any kind of a broad-based effort to address them? Because there's so much there that whether it's the funding, the regulations, the technology, there's so many issues there, and if there's not a broad coalition with dedicated effort, I don't know. I would be very skeptical that anything is going to really move forward.
I can say policymakers are a little bit frustrated about no one can give them a straight answer on, do we have enough capacity on the grid? And then that goes back to the information system about the grid. There is no information system about the grid and the assets on the grid. That's our industry. If there was, the instantaneous like you can imagine the people at Walmart and Amazon or whatever, they can instantaneously see where all the inventory is and see where it's going and see the, you know, the financial impacts of capacity. Policymakers don't trust that, because they're not getting any information about the capacity of the grid, because there's no information system about the capacity of the grid. So do we need more capacity? Don't know. Because no one's ever written down how much we use and how much we consume.
There are consultancies, Rick, that work on that. And actually, I was the building automation representative to the grid roadmap in 2003, which suggested we were going to run out of electricity 15 years ago. But a miracle happened, which is not discussed that often, which is LED lighting. LED lighting came in and conserved so much power that not only did we not need to add the generating capacity, but we had room to spare for decades to grow. Now, the problem comes in to, you know, how you look at these technologies. And as renewables come on and other technologies and efficiency, which is rarely talked about, that number moves in different directions. So there isn't just a steady curve of, you know, more population in the US requiring a certain amount of energy or new technologies coming on. As an industry, we're working on energy conservation all the time. And, you know, one of the hidden secrets that people don't talk about is we didn't need to build all those power plants that were projected in 2003 because we conserved that energy.
Well, now I think the whole answer comes down to 2 letters. Can you guys guess what 2 letters I'm talking about? Seems to be the answer to everything, every single problem there is.
AI.
All right, Rick Justice, you get the Jeopardy bonus question of the day. There you go. Just had to throw that in.
Well, it does bring up an interesting point. If AI can help with modeling, instead of the consultants taking several years to, you know, pour over all sorts of data, if AI can be used, if we can get the right amount of data to the AI engines, that's maybe the bigger problem.
Yeah.
They're still got to make the same decisions. If there's not enough power, they're going to have to look at what can be reduced. You know, whether it's all of Tracy's stores sort of running at sort of 75 instead of 68 or something or whatever. You know, at some point you got to make a decision, and it's going to come down to think whether it's AI or whether it's humans, and there's going to have to be some logic there that says, you know, we've got to reduce it because we don't have enough power.
But that logic at the edge, at the demand side, right?
Yeah.
Requires data, right? And it requires context, and it needs to understand what's going on, right? And it requires the sort of smart stuff that we're talking about.
The raw data is already there, right? Because a lot of the BAS systems already got all that stuff.
Right. It requires it to be used so they can make decision whether I can switch off that boiler pump now or whether I need another 15 minutes before I can do that, and therefore what is the cost of doing that. But all of the data is kind of potentially there. It's just not being used in this way. And I think that's the key of the system of systems, is that if you structure it in a way so data can be easily used by new applications, this then becomes one of those new applications that could use the data.
But it's going to have to mean that Trace's, you know, concept, which is an obvious one of all the, you know, a whole chain of smaller buildings, it's going to need all the buildings, whether it's, you know, whether you're an accountant, whether you're a solicitor, whatever it is, you're finding, you know, those buildings somehow are going to have to be coordinated because you're going to need that tied in. It's no good doing it building by building. It's got to be a common approach.
It goes back to the one word, interoperability, right?
Right.
Yeah.
But it's got to be that the users and other people are happy to share their information on their building.
Well, and also able to share, which is the interoperability point. Right? Being happy.
10 years ago, we worked on a series of standards in ASHRAE 201, that basically defines the building to grid interface. So there's been a lot of work done, but there wasn't the economic opportunity to put it to use. And maybe we're just getting there now.
Yeah, Jim, I'm glad you brought up ASHRAE because I was going to ask the question, my assumption is something like the Department of Energy working with utilities from the top down is going to be addressing a lot of these fundamental issues, but from the bottom up, from who's representing the owners in terms of what they want and what they need, right? And so as a group here, we're identifying interoperability and the various aspects of it to provide the information that's going to be required, as well as the control decisions. But I'm just curious if how much, whether it's ASHRAE or BOMA or IFMA, is there a organization out there that maybe we could interact with that is thinking in these terms that building owners can go to and say, hey, this is what we need from a utility perspective for the future if we're going to be bringing in solar and battery generation and cogen and all the different options that are going to be are desired. What kind of, because we're not going to, our organization, Monday Live's not going to do this. So it seems to me there has to be a large organization out there who can represent the owners.
Well, Ron Bernstein is on the call, and he's been part of the Gridwise architecture group, which Anto and I had a lot of interaction with 10 plus years ago. But Ron would be in a much better position in a more modern time to answer that question. Anto, maybe you could, if Ron's not going to join, you could be a proxy for him and mention what some of the things that are going on there are.
He says, okay, bring him on.
Bring him in.
All right, Ron, where are you?
Just while you're doing that, I had to stay between you and Anto's time and Ron's time on GWAC, and all of this discussion is not new.
Exactly.
This has been going on for a long time, for sure.
Right.
So,
All right,
Ron.
Hey, Ron, take it
I
away.
was trying real hard not to have to join in because I was doing other things, but because some of these topics are kind of near and dear to my heart, I thought I'd jump in and just say a few things. I had just put in the chat, you were talking about other organizations that we could reach out to. Well, actually, it's happening the other way around. Other organizations are reaching in. So in the last 24 hours, I made contact with the California Energy Alliance, who's an organization I've done work for before on policy generation and influencing. Think of them as lobbying, but also technical ability for the state of California. They do a lot of work with the Energy Commission and with the ISOs and so forth. And they reached out to me to learn more about the DIB 2525 project. And that came through somebody that I know that knew I was doing something on that. And we were talking specifically about the lighting industry and how the lighting industry is struggling dramatically with the advent of LED lights now diminish the value of a lighting control system and the energy efficiency that you can get from the old school control system. Now, most of the industry players are kind of dropping out of the controls for lighting because anybody can do it. And they're trying to figure out where they go. And that's where the California Energy Alliance is in coordination with them, trying to figure out where do we take the lighting industry and others as it relates to grid interaction. So a couple things there.
We think the hybrid working is going to have an effect, i.e. if the space is reduced and the buildings are empty effectively 4 days a week, in some instances. Is that the next big opportunity to save power?
Who's going to know the answer to that?
It needs managing, but it's an opportunity.
Hey, in my opinion, we're just shifting load.
Okay, so
we're just shifting it from
the home rather than
office
the
building to your single family home or your apartment, and people are getting much more power hungry. That's why we're seeing increase in the desire for home solar, some home generation, batteries at the home level, is because people are home more and they want to be able to conserve and have the right source of energy for what they need. So we're not minimizing the energy, we're just shifting.
So Roger, are you guys across the pond having these types of conversations like we're having today?
Yeah, we're getting struggling for availability of power. You know, we're going ahead with nuclear power, but it takes 14 years to commission a nuclear power station, right? And so we're going to actually have challenges as it comes along because we're not generating enough sustainable energy at the moment. So it's going to have, we're going to get to those points, and they have talked about the fact that as we get in more cars, there could be challenges where we might, UK's not typically gets that many outages, but they're forecasting that could come if we continue on down this path with, electrifying everything.
They've got more sensible regulation there as well, Mark.
True.
The other type of companies or organizations are sort of technology organizations. There's an organization called OpenADR, right, who is very focused on creating a demand response signaling standards that will go from an energy provider to a consuming entity, and it gets a little bit more complex than that, but that's basically what it does. And what we're actually working towards with the IBB is to have an OpenADR application in the IBB working to curtail demand. So that's and also the other organization is LBNL. It's actually been at the driving seat of a lot of DR and sort of building grid connectivity stuff. Rick, you want to spend a minute or so talk about that?
Yeah, the OpenADR organization, we're going to be demonstrated that at AHR. We're putting the OpenADR containerized virtual end node, I guess, in the IBB, and being able to demonstrate how the different than other systems that are also containerized in the IBB will be able to consume and produce signals to that OpenADR component. So that'll be really cool. And then we also will try and be giving like a recipe or kind of a handout or help to anybody who wants to make their system be able to reside in that IBB, and using the OpenADR as a great example of, if you comply with this architecture, you can easily get those signals and send data to the system, because the two-way nature of the information system is really important in OADR. So it's a really good proxy for system of systems demonstrations because of just the sheer nature of what it is. I wanted to point out also that with the technology for the information system side of this has gotten much better, and that's what a couple of people have touched on it. And then as Ron said, Division 2525 is the place where you can now articulate how you want interoperability to happen. And again, OADR and system of systems is going to be, I think, a great proxy for how the evolution of technology, along with the evolution and the changing needs of the owners, hopefully we're putting some structures in place that can help, match supply and demand. That was a mouthful. I was trying to work in F-150 into my little rant there, because a friend of mine that works in the utility space said, go look up what Ford is doing with the F-150 and the capacity of those batteries on wheels, and see how, to Ron's point, it's just shifting load or moving load around on wheels, which is kind of interesting.
Ron, could you bring us up to speed on what's happening in Gridwise architecture and ASHRAE and all these other organizations? Can you give us an elevator pitch on what's going on today on this topic?
I can. I'm seeing that it's now 1 o'clock on my calendar here. I don't have enough time in 2 minutes to do that. So maybe we can do that on a future call.
Sounds great.
So I'm involved both with ASHRAE, with the Consumer Technology Association and GWAC. and a couple others, all in this space of smart buildings to smart grid and the cross interoperability issues is where I come at it from. And interoperability, which is a broad topic for data exchange, standardization of data, the flow of data two ways. In the grid world, we call it in front of the meter and behind the meter. There's a lot of pieces of the puzzle there. There's a lot of standards that are being developed and initiatives that are going on. That's an hour conversation right there.
Got it.
I'd be happy to, Jim. I just can't do it. I have to leave here in a couple of minutes.
Oh, good.
Yeah. So another time, I would be happy to.
Good.
And I did post up in the chat a link for if anyone's interested in kind of a fundamental understanding of the impact of electrification of transportation. And that's not just cars, but transportation electrification. What are those impacts? That video from James Mader, some of you may know James from
Quality
Logic. I was going to say Grid Logic, but that's not it. Quality Logic. He's also been highly involved in OpenADR from the testing side. So I thought he gave a very good presentation on that just last month or 2 months ago.
Okay, thanks for that link. So I'm going to ask the question to quick fire question on all of us. Having spent the 3 weeks now on System of Systems, so I'm going to ask the question, is the System of Systems concept becoming a little bit clearer to understand what we're trying to do here to make buildings smarter? I'm asking this so that we can sort of try and figure out how best to spend next week. We've spent 3 weeks talking about it. Is it helping clarify sort of the challenges and the way?
So is this our lightning round? Yes,
Lightning
no,
round.
or
Yes,
plead
no,
the
I
fifth?
plead the fifth. Yeah, and I'm gonna go from around my screen, and I'll go from the bottom here. Steve.
No.
Okay. Jim.
Yes.
Ron.
I abstained because I haven't been on the calls for a couple of
Okay,
months.
fair enough. Rick. That's a yes. Roger.
Yes.
Tracy.
Yes.
Ken.
Yes.
Mark.
No.
Okay, so we have 2 no's and like 5 or 6 wise.
What's
yes.
your vote?
You didn't vote, Anto.
I think it is. I would say yes. Yeah, I think just by talking about it, it's just, it's kind of a talking about it over and over again. I think
That probably needed to be on a scale of 1 to 10.
Yeah.
that breaks the rules.
That's not acceptable for a lightning round question. Sorry.
Ken, a
Brandon.
single word answer. 4,
Well, yeah, just
6. Yeah.
All right, with that, let's bring this to a wrap. Thanks, Ron, for your contribution. Thanks, everybody else. Thanks for the audience, and we'll have a great Thanksgiving. Anyone that's in the US. Otherwise, we'll see you next week. Bye-bye.
Have a great holiday break, you guys. Enjoy your families.
Thank you.
Thanks,
Bye-bye.
Roger.